Let's take a look at number 5 in module 3B here, okay? So we're told in 2004, this is the price of the painting. In 1950, this was the price of the painting. Okay, so the first question is we want to find the exponential growth rate. Fair enough. So let's do that. Well, we know that we're going to have some initial value. They gave that to me. E, because it's growing continuously, to the RT. So we need to find what is R for this model. And the way I can do that is I can set up the price that they gave me, the price in the beginning, E to the R, solving for R here, and then how much time has passed. 2004 minus 1950, that looks like that's 54 years. So I can plug in 54 years there. All right, so I want to solve for R. Solve for R, okay? How do you do that? Well, you need to divide both sides by the 34, and then we'll take the natural logarithm, and then we'll divide by 54, and that's how we're going to solve. So natural log 8101300 over 34 divided by 54. Okay, that's what R equals. So the next hurdle is to plug that all into our calculator. You can plug it into steps if you want, or if you have a graphing calculator, you should be able to plug it in all at once. All right, there is our rate. So R equals 0.144. All right, and then you can see here, I just plugged in my model. All right, so now we have V of t. So we see that it is exponentially growing continuously. Okay, so that's part A. Fair enough. So the next part is predict the value of the painting in 2025. Well, I set this up as year 0 as 1950. So how much time has passed? Well, that's 50 and 25 gives me 75 years. So 75 years have passed. What would we predict the value to be? So I can plug in 75, and that's 34 E to our new growth rate, 75. Okay, so the next hurdle is to plug that all in. Okay, times E 0.144 times 75. And there we go. Okay, so this was my mistake, and hopefully it won't be yours. It wants us to round to the nearest million. Okay. And so to me, you would have divided by 1,000,000 and reported how many millions you have. They actually just want you to lop off all of these significant figures. Okay, so just turn those into zeros. That's where I messed up. I left that so I would remember to tell you guys to look out for that. So hopefully you can learn from my mistake with that rounding. It's just a rounding, but it is disappointing. Okay. All right, part C, estimate the rate of change of a painting's value in 2025. Okay, so what is going to be the value? This was predict the value of the painting. This is the rate of change. How do you find rate of change? Rate of change sounds like slope. So what is the slope at year 2025? Okay, how do you find this? Well, I think we're going to have to find the derivative. So I think I'm going to have to take the derivative of this function I found and then plug in the time. All right, so let's do it. So we have V of t equals 34,000 e to the 0.144 t. And we want to take the derivative. Well, this is e to a number. What did we learn in class? But that number just comes down. And it is still up here. It just came down because of chain rule. So we need to multiply those numbers together. Okay, so 34 times 0.144 4896 e to 0.144 t is v prime of t, right? So now we found the derivative. They want it at year 2025 in my version of the problem. We already talked about that was 75 years. So I'll find v prime of 75, 4896 e to 0.14475. And that should tell us the rate of change at that year. Okay, that's my next task, is to do that. 4896 e 0.144 times 75. And there we have it. $5,842. Okay, and they want us to round to the nearest million again. This time I did not make the same mistake. Once I figured out what they wanted here, I figured out that. So look out for that. Okay, that's the method they want. So all those sig figs are just going to go to 0. Okay, so that's part C. How do you get part D? How long after 1950 will the value of the painting be 5 billion? Yeesh. Okay, how do you do that? Well, 5 billion. That's a pretty big number, huh? That's like 5 times 10 to the 9th. Okay, so I want to solve for t because it says how long. So that sounds like, what does t equal if the output is 5 billion? So I'm going to take this and go 5 times 10 to the 9th equals 34,000. E, I know my rate, and I'm solving for time. All right, how do you solve for time? You divide both sides by the coefficient, then you take the natural logarithm to bring this down, then you divide. So that being said, it's the natural log of 5 times 10 to the 9th over 34,000 divided by 0.144, whoops, will give us the time. This will give us time. All right, so now I have to do that. Natural log, whoops. Natural log, calculator. There you go. Okay, 5 billion, or you could just write 5 times 10 to the 9th. That should work. Divided by 34,000. Divided by 0.144. And that is my time. 82.6. And they want us to round to, final answer, round to the nearest year. So that's approximately 83 years. Okay. So I hope that helps of seeing a word problem worked out for you. Yeah. So let me know if you have any more questions about that.